Let's talk about deep learning. Deep learning is a huge aspect of the cloud-based machine learning ecosystem for AWS, and it's all over the place in terms of services that are offered. And in the exam, you'll definitely need to know about some of the fundamentals of deep learning, and we're going to do that in this section. We're going to go through and talk about some of those fundamentals. So let's talk about just deep learning in general. Like, what's the history of deep learning? Well, there's a brief history of neural networks that from 1950 to about 1998, there was an academic activity around neural networks. And right around 1998 to 2007, there was an AI winter. And then from 2000 to today, we've entered the GPU era, and that's where Moore's Law has really ended in 2005. And so deep learning is a multi-layered feed-forward neural network. And a bit about the history here. When I was working at Caltech, I was actually working there in the year 2000. So I was actually around during the AI winter, and it was very common for people to discuss neural networks and how they had so much potential, but they were a failure. And even asked one of the computer science professors there, whether I should study basically neural networks, and he said that's actually not a good idea. So some of the smartest people in the world, computer science professors at Caltech, even thought that AI was dead. But as you can tell, it's really this emergence of the cloud and the GPU and the fact that Moore's Law is over. All those different things have actually created this opportunity for deep learning. And look at this perfect storm here: cloud computing, end of Moore's Law, also elastic storage and compute. It's one thing to have your own data center that has, let's say, a terabyte of data. That's another thing completely entirely different to have an infinite amount of storage and an infinite amount of compute. Those factors combined with this GPU era really have set the stage for being able to do the kind of deep learning that we're able to do. Also, it's one thing to have all those abilities and all those powers, but you also need this proliferation of data. So social networks in particular are a harvesting center for a rich amount of images and data and preferences and political beliefs. All those things are really the feeding ground for deep learning. Now let's talk a little bit about neural networks. Here's an example of a deep neural network. And you can see here that this is a neuron. This is the first input layer. And a deep neural network, one of the ways to differentiate it from a regular neural network is that it has multiple hidden layers. So we can see here's hidden layer 1, here's hidden layer 2, and here's hidden layer 3, and then finally this is the output, right? So you have this whole process where slowly things are transformed. Simple functions are collectively trained in layers, and they slowly turn into more complex functions. And really this is the process to be aware of: is there's input layer, there's hidden layers, and there's output layers, right? So these are really important concepts to understand for the exam. In terms of recurrent neural network, you can see in this example everything went from this direction all the way to the output layer. So it's one directional. But a recurrent neural network, again, these are the things that are used for creating self-driving cars or drones or automatic speech detection. These are all networks where things are actually cyclical. So you can see that even though the direction from the input layer to the hidden layer is this way, inside here there's a feedback loop, right? So speech is a great example of that, right? So there's a sequence of data, and you constantly are feeding back things into this network so that it's learning more and more about the data so that it can finally make this great prediction. RNNs are used in sequences in particular, so text, speech, translation, self-driving cars. Now let's talk a little bit about deep learning use cases. So what are some deep learning use cases? Text analysis is really one of the big ones. So can you detect insider trading? Is there some comments that are on the company message board that you could look at and say, okay, I think there's some insider trading happening. Sentiment analysis. So, let's say you have a president that is making a tweet. Is it the president upset or is the president happy? Are members of the Congress excited, or are they, neutral when they're saying something? These are all things that can be detected through social media. Now that all of our politicians are on social media, we can actually get this sentiment. Regulatory compliance, you could actually run through and look at all the different data that's being created from, let's say, a food manufacturing company, and you could actually detect hidden patterns. Also, brand affinity. You could see from tweets on social media, are people liking this brand, and would they like this brand based on their activity? Also, intent analysis. These are all things that can be discovered with text analysis. Now, in terms of time series, we know that financial data is a really interesting area for time series data. So being able to predict stock prices. Log analysis is another time series problem that deep learning is great at. In particular, SageMaker has some built-in time series abilities. There's also supply chain. This is an example of something where you could look at the procurement, for example, and say, I have $1 billion to spend because I'm a very large company, and I need to decide exactly where to pick the best suppliers so that I get the best ROI. Finally, IoT. IoT is an emerging area of technology, Internet of Things, where all these really small devices are emitting packets of information. It could be your refrigerator, it could be a shirt that you're wearing that's emitting your heart rate. These are all areas where they're going to emit time series data, and then deep learning can actually do predictions based on that. And then finally, another deep learning use case would be recommendation engines. So social media in particular is a great example of that. Now let's go ahead and talk about deep learning AMIs. So it's impossible to do deep learning on the AWS ecosystem without talking about the deep learning AMIs. Really, there's three styles of deep learning AMIs. There's a Conda-based AMI, and you may wonder what Conda is if you're not familiar with the Python ecosystem, but Conda is essentially a packaging system. So if you're familiar with RPM for Red Hat, or apt for Debian-based packaging systems, it's really similar, but it's for the Python world. So the AMIs have support for this because so much of machine learning now is Python-based and also deep learning. There's also a base AMI, and this has really the default Amazon Linux and all the AWS tools on it. And then also you can have AMIs with your own source code. Finally, these deep learning AMIs are available in several different formats. So they're available as pay-as-you-go, and typically that's the most expensive way to use Amazon resources. And this is definitely something you could be asked is, when should you use on-demand instances for a machine learning job, and when should you use spot instances? Now, spot instances are this market where you can actually basically bid on resources that are currently underutilized and save up to 90%. So often you can actually use pay-as-you-go, for example, in the case of on-demand, or these spot instances that can save up to 90%. So we can also perform multi-GPU training, and this is an emerging area of GPU-based deep learning that's important to know about, is that deep learning AMIs can actually support this concept of multi-GPU training. So for example, you have one instance that is fully saturating every single parallel capability of a GPU. Well, what do? You can actually distribute that machine learning training or deep learning training job to multi-GPUs, and that's something that the deep learning AMI infrastructure supports. Finally, it's preloaded with all the frameworks that you would need. So TensorFlow, MXNet, Gluon, Chainer, Caffe, Theano, PyTorch, these are all frameworks that you have access to. So it's really possible that you could be asked something about a framework and how you could get access to it, and it may be that they're referring to deep learning AMIs, so definitely worth brushing up on those deep learning AMIs and making sure you understand how they work.